Welcome to Black Hat Windows Security Conference 2002, held February 7th through the 9th in New Orleans, Louisiana. The following videotape was recorded live at the conference and produced by the Sound of Knowledge Incorporated.
Actually, you can download the presentation. We were in the process of putting it up on the website so everybody can download it right when Wayport went down. So it should be up there probably now. So if you guys want to grab it, grab it. Okay, still have some people filtering in, no big deal. Are we rolling on the camera? All right, good deal. All right, so thank everybody for coming to the presentation. Who am I? My name is Steve Dugan. I am a CCSI, which is a Cisco Certified Systems Instructor, which means I'm used to standing in front of a group of people. Gee, I was expecting a full room, so, well, a group of people about this size. I teach a wide variety of the Cisco classes, but I am not a Cisco employee, which means I can, tell you the truth about what's really going on. Let's see, focus the presentation. There was so many things for me to cover as far as securing your infrastructure that I had to just pick some things specifically. So my presentation is going to be focusing on hardening your Cisco routers and hardening your Cisco Catalyst switches instead of going full-blown into IDS and firewall and VPN and all the other solutions that Cisco offers, which is pretty much everything. That's going to be my focus. Now, why talk on Cisco at a Windows show? Okay, this is the point at which I was supposed to figure something out to answer this question, and I still don't have an answer. Okay, there's another side of this there. If I tell a joke, and that may not have seemed like a joke, I'm expecting some kind of response, maybe in laughter form or something. Throw that joke out too. Okay, I see how this works. Group of security professionals that are really uptight about their job. Okay, I get it. All right. Well, hey, it's, Windows runs on what kind of network unless it's just sitting there by itself, and it's pretty secure that way. All right. How will the material be presented? I'm going to flip through these slides really fast because there are like 60 of them, and I got to get through them in an hour. So here we go. All right. We're going to break it out into 3 sections. Section 1, I'm going to talk about how to get into the box, how to get management information out of the boxes on Cisco routers, and how to turn off all the things that are on the box that should have been turned off by Cisco in the first place. Then we're going to jump into some layer 2 issues, talk about VLANs, VLAN design, get into some of the little attacks that we've seen, VLAN hopping, network sniffing, see if we can figure out some ways around those. Then we're going to jump into layer 3. I'm going to introduce some access lists, but I'm just going to tell you what type access lists there are. I'm not going to go into how to configure access lists. We don't have a full day. All Cisco access lists are, if you don't know them by now, then, oh well, come talk to me later. Jump into some IP routing protocols, how to turn on all the authentication features for all the Cisco routing protocols. And then we're going to jump into HSRP because, well, just because, again, of FX that told us how we're going to destroy HSRP, so I'm going to tell you how to fix it. All right, so section 1, first part here, we're going to talk about turning off all these unused features and turning on the things you should be using. All right, when you boot up your Cisco router that has no configuration on it whatsoever, what is turned on that you should be turning off? Ugh. A whole bunch of stuff. And a lot of these have well-known exploits or many well-known exploits. So here's all the commands to turn all this stuff off. Turn off small servers, both TCP and UDP. That covers echo, character generation, discard features. There's several ISPs that have been denial of service attacked just based on those 3 protocols alone. Finger. Finger works great if you use it in conjunction with the most commonly used protocol to transport your configuration and your flash files around. Finger the router. What's the host name? Okay, let's find the TFTP server and type in hostname.txt and get that file. What do you want to bet that that's your configuration file on your TFTP server? Lucky guess? There's other ways to find the host name, but All right, boot P, and we're using that, right? Auto install. Oh, actually that's a useful feature if you're using it, and I've never seen anyone use it. That's the feature where you get to take an unconfigured Cisco router and plug it in. Never been configured. As long as it's got a live serial link, it'll come up. It'll do a SLARP, that's a serial line ARP, to figure out its address. It will then go through the process of doing a dynamic TFTP GET request to get its configuration. It's pretty cool. It's super insecure, but kind of a cool feature. Turn it off. And there's other ones. Oh, the no IP domain lookup thing was added on there because it just annoys the snot out of me every time I type a bad command on a router and it comes back and sits and waits there for 15 seconds as it's trying to do a DNS lookup for a command that I fat-fingered. Okay. All right. Interface level things. IP unreachables. Stop sending unreachable messages on your router. Proxy ARP, we all know what that does. Source routing, actually I skipped that in the last page. Some routers have the command on the interface depending on the iOS. Some will do it globally with no IP source route. Some routers you can do it both at the interface or globally. So I would type the commands in both places. If it doesn't take the command at the interface, then it was already turned off globally, you're fine. There's no reason to be using source routing today, and most reasons for source routing are for hacking tools, so it's a good reason to turn it off. No IP directed broadcast. Now that's defaulted on all images after 12.0. That is the main line of defense against Smurf attacks and other denial of service attacks that take advantage of hitting the broadcast address. All right, features you should turn on. Nagel. Everybody know what Nagel is? Okay. Most people use Telnet to get into their routers, or they have interactive traffic running back and forth in routers. When you guys were learning that OSI model thing, right? Remember that thing? Application, yeah. Telnet is the perfect example of the most bloated protocol I've ever seen running anywhere. Because the process of going all the way down that OSI model encapsulates a single character with a TCP header, IP header, Ethernet header, one character. Nagel, the Nagel algorithm essentially just stores a buffer of characters and then sends a large packet of, a string of characters instead of one character at a time and generating huge amounts of interactive traffic. Without it on, you could run exploits against Telnet and just start shooting a whole bunch of traffic over and see all this little tiny traffic on your network, but it is exploitable. So we're all familiar with login banners. Don't put welcome in. We all know all the stories on that. By the way, YWBP TTFEOLT, you will be prosecuted to the full extent of the law. I didn't have enough room on the slides, so I just abbreviated it. All right. Other things. Now, if you're running at least a 2600 or higher, and of course recent code, you should be running Ceph. Okay? This is not, for all intents and purposes, is not a security feature, but it'll lead into one. It will give you a boost of performance probably up to 25% just by turning it on your router. Just by the way it handles taking IP routes and pre-caching all the next hop MAC addresses and everything it needs to do for a forwarding information table. Right. Excellent feature. You should have it turned on. Yes, sir?
What about the service provider space?
Why not? Give me an example. Okay. I'd have to see how you would get the cache information off the router.
I'll pull it up and we'll get back to that.
Cool. Hey, I want to see that because I haven't seen any exploits against Ceph. I do know that at a service provider environment, having Ceph gives you the ability to run the unicast reverse path forwarding. Okay? Now that is going to somewhat protect you, or at least be able to detect a wide variety of the distributed denial of service attacks that are out there, and that's what I have diagrammed up here. It's a requirement that you have Ceph to use this feature. Essentially what it does is it turns your router into, it looks for forced asymmetric routing. If you got a route come in, like in this case, we have an IP address of 192.168.8.1 with a odd bit mask there. As that comes in, if you look at the source address is on that subnet. That's coming into the router, and the router goes, wait a minute, how would I, by any fathomable imagination, forward a packet back out that serial 0 interface if the source address is on my Ethernet network? Or at least it should be. So it's verifying the source address to make sure it can reach it, and reach it back out the same interface it went out, or rather that the packet came in. So in this case, it would end up dropping it. Everybody understand what this is doing? Does that make sense? All right, now the only problem you have with this feature is, one, you only want to turn it on where you have an asymmetric environment. Inside of your enterprise, where you may have multiple routes to a destination, load balancing and so on, or just simply by the nature of routing, this is not a feature you want to turn on for those interfaces. You might want to turn it on for your dial pool. Okay? Dial pool is another commonly exploited place for distributed denial of service. You want to turn it on for your external connection off to the internet, unless you're running BGP and you're multi-homing to the internet. Now, if you're multi-homing, then you're going to have to play with some weights and local preference values to make sure that you are getting asymmetric route information from your carriers. Like, half the, if you're getting full-blown internet tables, let's say half the routes go out this carrier and half the route go out the other. It'll still support BGP's reliability, because if one path goes down, you're still getting all your asymmetric paths over the other link, so you're okay. All right, oh, by the way, I have some links at the end. If you see the little chain link thing there, I got a link to PacketStorm's website for updated distributed denial of service attacks. Yeah? Yes. Anti-spoofing ACL solve a lot of this. It will, but a lot of times again, notice that my wording up here was RF reverse path forwarding helps distributed denial of service detection, not prevention. Because if it's coming from legitimate addresses out on the internet, this isn't going to help. But it is going to help you in detecting it, okay, in seeing what's going on. But if they're spoofing addresses internally, then this is just going to drop it immediately, and it's going to do it a lot more efficiently than an access list, because it's already cached based on Ceph. Okay, so it just dumps it right away. Good question. I like questions, so if you guys got questions, just fire away. All right, let's see, device access options. Talk about console and auxiliary and so on. All right, console access. Physical access to the box. First, get a Cisco router. That's really the only way in. That's it. Use it for your initial configs. Put the information on. You need it for other management purposes. It's pretty easy to get around the passwords on a Cisco router. I'm going to show you all the commands to do password recovery here in a minute. So again, if I've got physical access, I don't have to worry just about password recovery. But hey, people are just going to take the box, put it on eBay, sell it. Physical access is a major concern, especially for any Cisco device, because they are very compromisable very quickly. That includes right up to your PIX box. Okay? If you have physical access, you own the box. That fast. All right. Ways you can protect it a little bit. You can put all these different console passwords up there. You can use TACACS. That is saying that people aren't going to just run password recovery and get around it anyways. Doesn't matter how secure it is. That being said, there is a secret iOS command on certain versions of routers that disable password recovery. Can't see it in help, but it's there. I'll show it to you guys in a little bit. Does anybody know what I'm talking about? Anybody run it? I know FX has seen it. We were talking about it last night. All right, the aux port. I actually like using the aux port more than the console port because it has a full 8-line TTY port. I mean, it's not just transmit, receive, and ground like the console port. It really has carrier detect and CTR, RTS. But here's all the things. Set the login. What am I usually going to use the aux port for? Dial-in access to the router, the switch, if everything's down. It's my remote method of managing a box that I just can't get to anymore, instead of getting on a plane and going somewhere. That being said, if you're going to attach a modem to a router, it's just as vulnerable. Now, you can't do password recovery off the aux port, which is nice, so you couldn't remotely do it. But it's pretty dangerous to go attaching a live modem with telephone number to it when you're only using it for a last resort type scenario. So I suggest if you want to use that, go ahead and have that modem there, but unplug it. Don't let anybody use it. Lock it down, proper passwords and everything. I put the simple option up here. Just put the password. You can use local login and put in a username and password, or you can use Attacktecs or Radius or Kerberos. I put the Attacktecs example up here. All right, VTY access. Here's some of the issues I have with this. Number one, unconfigured, the VTY port on a Cisco router takes just about every protocol that you haven't run for years and supports it. Okay? Things like MOP and LAT and PAD for X.25. Oh, and yeah, Telnet too. If you're not running that stuff, shut it off. As a matter of fact, why are you configuring a router with Telnet today anyways? Okay? Yeah, I know, it's more expensive to go buy the IPsec version of iOS, but if you have that, run SSH. Okay? So here's some things you want to do. Lots of different attacks. You can flood the router with telnets and do denial of service attacks on it. Man in the middle, if I'm sitting on the network with any of the multitude of tools out there and watching traffic go by, all that telnet information is sitting there. Okay? Might be one character at a time if you don't turn Nagel on, but I could put everything back together and figure out what you're doing. What you need to do is you need to use this transport input SSH or transport input telnet if you don't have the SSH code. At least turn off all the other capabilities. SSH would be optimal. If you want to run SSH and telnet, you can put both of those and support both of them and still turn off all the other things. You just do transport input SSH space telnet. Another option is turn it off completely. Transport input none. There you go. Now you can't get in. That may be a more viable solution for you. If you're local to the router, just use, if you have physical access, if you can walk in and get to the router, use the console port. Let's see. Thing is, Cisco management is designed for this kind of access. It's the way they've designed it. So it's really useful to be able to telnet to and from your devices in your network. I can't deny that. From a management standpoint, in a large network, being able to move around the network is important. But take care of it. All right. Oh, also on the SSH note, I got a big old note here. Cisco has had some active advisories regarding SSH, so you might want to read that advisory before you go run SSH. Even still, it's much more secure than Telnet. Even if you're susceptible to the attacks on SSH, it's going to be a lot more secure than Telnet. Yeah?
Are they based off the OpenSSH code?
Yep. Same kind of attacks.
So it's a CRC32.
Yep. Mm-hmm. But there are fixes for it if you have the right code. So you just make sure you have the right code on your routers and your switches. And I'm putting the commands up here for the router, but I'm going to show the commands for the Catalyst switch, the set-based commands here in a minute too. So you guys will get those. Also, there's another link there, so there's some information, more information on configuring SSH. All right, password issues. All the different types of passwords on our routers. We're going to talk about what if I don't set the password or type in no password. What's the deal with Cisco's encryption technology that they use on their devices? And then password recovery techniques. So 3 levels of passwords on a router. User exec, privilege exec, and you can create custom levels. User exec still needs to be guarded, but if you got user exec on a Cisco box, what can you do? Not much. You can look around, show IP routes. You can look at some of the tables, like BGP tables. You can look at the ARP tables. You can't do any configuration. You can't see the configurations. You can't turn on somewhat destructive features like debug, IP packet all, detail, which could cause some problems. You can't do what people commonly use for Smurf attacks, which is the ping tool on a Cisco router. Right? You can't do extended ping. You can type ping in an address. Excuse me. But, all right, so privilege exec. This is essentially the root for the box. You get privilege exec, you own the box. You can do anything you want. If you had console access, you can still own the box. But privilege exec, all functions, all capabilities of that device are available at your fingertips. Okay? You are dangerous. Custom levels can be created, and this is often done in large enterprise or service provider environments where you have multiple levels of techs. They do inherit the level, so level 2 will add abilities to what otherwise weren't available at level 1, and so on. You can also create deny, so you actually remove things from capabilities as well. I don't see it used too often except for in really large environments. You could also use the authorization portion of AAA from Attacktecs or Radius standpoint to turn on these capabilities for exec commands and so on. All right, what happens if I don't set the password? Well, it depends on where I'm at. If you don't set the password on a VTY port, what happens? Because by default, the Cisco router says VTY, all 5 VTY lines, we're going to log in. But there's no password set. So what happens? Unconfigured Cisco box, I go in and put an IP address on it, and I go somewhere else in the network, and I telnet to that box. What's going to happen? Somebody knows. Nobody? Huh. It comes back and says, login required, but password's not set. Goodbye. Hangs up. So by not setting the password on the VTY ports, you're not going to be able to get in. Matter of fact, to go one step farther, if you don't set the privilege exec password as well, you set the VTY password but didn't set the privilege exec password, if you telnet into most Cisco boxes, you'll get user exec, you'll type enable, won't let you in without a secret password or enable password. I wouldn't bet my life on that without testing it, okay? I know for sure that no password on VTY though, on all Cisco boxes that I've ever run into. The same is not true for the console and auxiliary port. If the console port's set for login or the auxiliary port's set for login and there's no password, it'll let you in. It won't even ask you. So on those particular cases, if you ever wanted to disable the console or auxiliary, you could turn off, transport input, transport output, set them to none, and then do no exec, meaning no exec prompt on the device. So the console and auxiliary would be disabled until you powered off the box and did a password recovery, and hey, funny thing, all those configuration commands just go away. All right. Password encryption. Most passwords stored on Cisco boxes are clear text or should be clear text. That's even if you type that service password -encryption command. The service password -encryption command does a very, very weak encryption technology. So weak that a friend of mine and I sat down and within 40 minutes on pen and paper, we decoded it. Okay? To give you an idea. There's more tools for your Palm Pilot to crack the Cisco weak encryption that'll do it in a quarter of a second. You don't even blink. I did it last night on Black Hat's router. They gave me to test. They didn't tell me the password, so I hacked it. So what do you do instead? For the secret password, that is MD5 encrypted. That's the password that gets you to the enable prompt. That's what you want to set. There are other MD5 passwords on the router. If you're ever typing a password and it's asking you what type of password, a number between 0 and 7, type 5. Okay? It may not take the password. It may come back with an error and say, oh no, we don't support type 5 for that password. And then you're stuck doing type 7, which is Cisco proprietary encryption that's really weak. But I would try it. On every password, on every router you get, try type 5 for all the passwords if you can do that first. If it doesn't, then at least try the weak encryption. But again, the weak encryption is only going to protect you against somebody staring over your shoulder watching the config go by on your screen. Right? If anybody has that information, figure it's been compromised. All right, password recovery on Cisco routers. Now, actually, I didn't put the information for Cisco switches, so I'll cover that too. It's as simple as powering off the box. Power off the box, console access, power back on. Hit the break key as the box comes up. That could be on your PC, control break. If it's a Weiss terminal, hit F5, or they actually have break keys. Okay, doesn't matter. Send the break sequence to the router, and it's going to put you in ROM-MON. ROM-MON's equivalent on a router of BIOS on a PC. At that point, depending on the platform, you're either going to change the hexadecimal address, the registry address to 2142, or you're going to run a program called, a script really, called confreg. Inside that confreg script of questions, there'll be a question that says, ignore the system configuration info, yes or no? Say yes. And then reset the router. When it comes back up, it's going to ignore the start of a config file, which is stored in NVRAM on the box. Comes up, unconfigured box. But all the information, all the passwords, everything is still there on the device. It's all sitting in NVRAM. It's just not in the running config, being two different configurations on a Cisco router. There is a way on some boxes to get around this. Discovered this by doing some hacking through iOS. There is a command called service password-recovery, or the inverse, of course, being no service password-recovery. If you type this in, when you reload the box, there's this, well, actually, first of all, when you type this in, it comes back with this nice long paragraph of, you better not do this, or you're not going to be able to get back into the box if you don't know the password. You better find another way around. Okay, say yes. Turn the box on, turn it back on, issue the break sequence, and try and do password recovery. It has this big, bold message as soon as you turn the box up that password recovery has been disabled. And if you hit break during power up, it'll come back and ask you, factory default, yes or no? So the only way to break into the box at that point is to kill everything that box knows about, meaning all of your passwords that are Cisco proprietary weakly encrypted sitting on that box. So those all go away. Yeah?
One question to that. Is the ROM-MON still working itself?
I wasn't able to get into ROM-MON when I tried it. Because I hit break and it just issued back all these hex codes back to me every time I hit break, so it wasn't going into ROM-MON at all.
Okay, because if you would be able to get into ROM-MON, you could use inspection commands to finally get the password.
Possibly, but it locks you out of ROM-MON, I think. It's the effect of the password recovery option is to lock you out of ROM-MON, and then if you issue a break sequence, that it's going to prompt you to either factory reset the box or not, and attempt to brute force the box. So, now, that being said, I just gave everybody in this room information that's pretty much public knowledge. I mean, you can go out and do a search for undocumented Cisco iOS commands, and you'll find some rather useful ones out there that you can't find through the help functions. But that's one, most of the undocumented ones, you call Cisco TAC to get support, and they're not going to help you. So, they're not going to be able to break in. All right, management protocols running on your router. CDP, this is how everybody else discovers your network, because as soon as you turn it on, which, by the way, it's on every box, you may look at it once, and then the only reason anybody else would use it is they're breaking into your network. It's the only use I have for it. SNMP, we all know about that. NTP, what time did they break in? Syslog, talk about that often ignored thing that we turn on and just forget about. And loopback interfaces. So let's see. CDP. You can use it to discover your network. That's what it's there for. Every single Cisco device, switch, router, other devices, maybe not the PIX firewall, I think that one's not turning CDP on. But pretty much every box that has a Cisco logo on it's running CDP on every interface. And it's sending these 60-second broadcasts and sending out lots of information that you don't want other people to know. What iOS rev is it? Let's just run that against what exploits are out there. What's the host name of the box? Version 2 tells you what the native VLAN is on it, which now you can run VLAN hopping against it. There's more information in CDP to run. Just go to your database of exploits against Cisco routers, and you'll have all the information you need just from CDP. My first suggestion is shut it off completely. To turn it off at the router, no CDP run. Do it at the global config prompt, it's off completely. There's a problem with that. A lot of people run Cisco Works 2000. Cisco Works 2000 and CDP don't work without each other. So now I got to come up with another solution to deal with CDP. Here's my suggestion on it. If the users never see CDP information, that's about as secure as you're going to get with CDP. So when you start getting into VLAN configuration, you want to make sure that every single user port has CDP turned off. The only ports that should have CDP turned on are boxes that are directly connected to other Cisco boxes that don't have any other hosts on that segment. And then you could turn it on, turn CDP off for all the interfaces that don't match that criteria. It's the only thing I can tell you. Otherwise, if you're not running Cisco Works 2000, shut it off. All right, SNMP, which stands for Simple Network Attacks Made Possible. Yeah.
For the CDP, if you turn off the CDP for a certain switch port, is that like passive or is that like off?
Off. Doesn't accept it in, doesn't send it out. It is off. Although I haven't fully tested that, I'm pretty sure that it is off. Because you do a show CDP on a router that's been turned off, it says CDP is not enabled. So it comes back and said it's not there, which is a far cry different from like IGRP and passive interfaces, which still take IGRP routes, or RIP, the same scenario, still take the routes in because it's listening passively. Okay. If you need to run SNMP, again, this could come down to Cisco Works 2000 or HP OpenView. We all know the exploits against SNMP is widely known. We know that people are going to leave public and private sitting on. You just sit there with any SNMP tool, you download off the internet, and public, private, let's see what we can see. Did it in a school system out in California. We were doing a Cisco Works 2000 class. Well, let's see how many devices we can see. We had to stop because it not only discovered their network, but next to them, and we had about 1,000 devices before we had to shut the thing off because it just kept going. Public, private, everywhere. If you are going to use SNMP, only turn on the read-only string. It's bad enough having to turn that on, but don't have a read-write string. Okay? It is very insecure. A good method to deal with it is create access lists. So the SNMP community is pointing to a particular access list that only permits a certain host to actually send GET requests down to the router, okay, as far as SNMP gets. If you're going to use read-write string, then look for an application out there that's supporting version 3. Version 3 of SNMP, is it out of draft form yet? I haven't looked in a while. About to go full standard? Good, about time. Supports triple DES. All we need to say about that. So it's a lot more complex to configure than just the view or the community strings commands, but yeah, we're gonna be able to encrypt all the information for the management as it should have been a long time ago. All right, syslog and NTP. Now I pick on syslog here because everybody turns syslog on. Oh, let's just log everything. And you end up with this huge log of stuff that you're just not going to read because it has way more information than you're ever going to look at. But it is, it's useful. Very useful tool to turn on. We all know logging our boxes is important. My point on this is if you're going to log it, look at it. Right? That being, I got 1,000 devices in my enterprise. How am I going to look at all those logs? Well, get something to manage it. Is that a question back there, or just kind of a moving pen? Okay, cool. All right, logs aren't much use if you don't know what time the log actually occurred. So synchronizing the time on all your Cisco routers and switches is important. Running NTP is a very, very efficient tool for synchronizing the clocks and the routers. It's authenticated. You can use the NTP authentication key. It's MD5. It works great. And like I said, it's very efficient. Maybe one packet every 2 minutes or something, just to maintain within several, just a couple milliseconds of time on different boxes. Also, there's one thing I missed up here because I ran out of room. Service timestamp, log, date time, and local time. There's also another option, milliseconds. You got to write down a millisecond on those logs as they get sent off. All right, loopback interfaces. This is something you don't get a lot from Cisco. They don't tell you about things like this. This is going to make your life easier if you do things like this. Turning on a loopback interface is the one interface on a router that never goes down. And because it never goes down, you can utilize those features to your advantage. What I mean by that is, number one, security aside, right? Routers have multiple interfaces and all of them have IP addresses. And the idea of a router in the IP world is to be resilient. If one interface goes down, let's try to find another way around to get some other part to the same part of the network, right? Using our dynamic routing protocols. Well, what happens if you were using some kind of peering protocol and you were using that interface that just went down? And a peering protocol example would be BGP. Could be, I don't know, things like DLSW, voice over IP. Right? All these are going to create a peer relationship between two routers. If the interface that they're peering to goes down, what happens to the peer relationship? It's dead. Having a loopback interface is going to help that. Here's how it's going to help from a security standpoint. When you telnet out of a router, it picks the interface that it leaves as the source address. So how many access list entries do you have to make sure you're only getting those telnets or SSH connections from a router or a switch in your network? Well, switch is a little hard. Switch doesn't do loopbacks, but so here's all these commands up here. IP telnet source, set it to loopback 0. The TFTP source, if you're using it. FTP source. You can also set the logging source. What happens if the logs start coming in from a different direction because the network link went down? Boy, you want that log, right? But the log's coming from a different IP address, so now it's showing up as a totally different device in the log. Setting these things will help you immensely. You can also use it for OSPF and BGP to force the router ID. Yes?
You shouldn't rely too much on loopback 0, especially for non-stateful access lists, because sending various strange traffic to a Cisco device that actually causes ICMP error messages coming back. These error messages often have the source address of the loopback interface as well.
Mm-hmm.
So if you build your security, what I've seen often around the fact that nobody knows your loopback IP address.
Oh, no, I never said that.
Okay,
My idea here is that if I'm configuring another device to make sure that I have an access list in place that only is allowing telnets from this router, would I want to configure an access list that checks every single possible interface on the router that may be in the future or is right now? Or would I want to configure the access list that says just allow this source to come in because the source is going to be based on that loopback interface? Agreed? Now, I'm not saying that loopback interface isn't going to be known to the network. I'm saying for configuring access lists later on in other places, it's going to make your life easier. For making sure the logging comes in and is coming in from the correct device, it's going to make things easier. Any other questions on that? It's a good question. I always get the best questions from other speakers. Of course, they were told to heckle me, so that's okay. All right, cat switch options, pretty much the same options I was just talking about here before. So as far as setting the passwords on the switch, password command's a little different on the switch. You can set the password. That's the user password to get in. It's the set password command. You hit enter, then it asks you what the old password was. Type in the old password, new password, retype it, etc. Enable password, same scenario. Did I do password recovery? No, I didn't. Okay, so password recovery on a Catalyst switch, at least the set-based switches, It'd be 3,000s up to 6,000s and so on. Password recovery is, again, very simple, even simpler than a router. If you have console access, power off the box, turn it back on. As it boots up, as soon as you get a user prompt, all the configurations load, but as soon as you get a user prompt, type enable. Type set enable password. You have 60 seconds from the time that that thing gives you a prompt to get in here and change the password, because it's not going to ask you for a password until 60 seconds has expired. And all the configurations are there, and there's no secret iOS command here. Okay? All right. You can turn SSH on now at a good many of the Cisco switches. There is a new alert that just came out on the 29th of January, last week, that the Cisco Catalyst switches are vulnerable to an exploit against BSD Unix that's been out since like June. They just never tested it against a Cisco box. And yeah, it just totally jumps the box. So here's Cisco's workaround. As of the 5th, was that yesterday? They've got code fixes out there, so you can download code fixes for your Cisco boxes. Or, I have a better solution, don't even bother getting a code fix, run SSH. Run SSH and you don't have the telnet problem, and you solve a whole bunch of other problems as well. You should also be using IP permit lists on your access switch, on your Catalyst switch. The IP permit statements essentially say what addresses are allowed to telnet into this box and manage this box. Okay? The equivalent of an access list, even simpler, more simple to configure. All right. Also the HTTP server. Did I even say that on the? I think it was on there before. If I didn't say turn off HTTP server on the router, that's one of the things that you should turn off like right away. You can go back and go look once you have the presentation. It's also on by default on a Catalyst switch. Now the Catalyst switch's HTTP server looks a lot nicer, but it still has the same level of exploits. It's not SSL, so you still get all the information, everything you ever wanted to see, and there's even some other denial of service attacks against it. So I suggest turning it off. I'm a command line person. I just rather sit at the command line and put all the commands in the way that they should be instead of looking at a nice GUI interface. If I want a nice GUI interface, I'm going to go out and go get Cisco Works 2000, and then I can look at all the lights and pretty pictures. But, all right, fair enough. Other things, NTP, syslog, here's all the commands. Now the logging server, Cisco recommends changing some of the logging levels. If you read some of Cisco's recommended practices for Catalyst switches, changing the spanning tree level. Spanning tree level by default, I think, is a lot lower than that, and you should be logging that information. Same thing with sys and server severity. So here's the commands to bump those levels up, just in case you ever wanted to know. Another thing I didn't mention before. Console logging. Default on for Catalyst switch and default on for Cisco routers. Every message that otherwise would be sent to a syslog server, still sent there, is also sent out to the console port. Now I mentioned before that the console port has transmit, receive, and ground. That's it. No hardware or software flow control whatsoever. So if there's a message going out that port, the router has no idea whether you have a terminal there or not. So it's going to send it. How fast does that console port operate at? 9600 baud? This is what I call it, an administrative denial of service. Administrator goes to the box and types in debug everything and then walks away. The router's highest priority is to handle those console messages. And as soon as you get a whole bunch of traffic and all that debug starts pushing out, the console says, hey, we've got to send this information out. And all of a sudden the console buffer fills up. And the router issues warning, console buffer is full, which overflows the console buffer and issues another command, console buffer full, which issues another command and kills the box. I suggest on both Cisco routers and switches shutting off console logging. As soon as you have syslog turned on, there's no reason for it to be here. It's a lot better to ship that information over an IP packet. You're not going to run into, you're not going to run into that kind of problem. The NTP commands for a Cisco switch, they're identical to the router pretty much, except for there's the set command in front of it. All right, section 2. All right, get into some VLAN stuff. How am I doing on time? Doing okay? Okay. All right, so first thing we're going to talk about is VLANs. Are VLANs supposed to be there for security purposes? The biggest contention problem I have. They are not a security mechanism, although they're very often used as security mechanisms. The other problem I have with VLANs is that people use VLANs as an excuse to create really bad designs. Now, granted, that's the way it was done 4 years ago, 5 years ago, but I think a lot of people have come back and said, you know what, this doesn't need to be done this way, and it shouldn't be done this way, because what happens in a large switch network, if you're running VLANs everywhere, is what does spanning tree look like? Spanning tree can get really messy, and if you have VLANs everywhere, it's not only going to make your network admin life miserable, it's going to make security miserable. So a good design for your VLANs is going to simplify your security. Here is my method on Cisco boxes. I'm going to show you the switch block design here. It's Cisco's best practices for design. Really what it comes down to is on an access layer switch, you're talking about two VLANs for users, one management VLAN that's not VLAN 1 anymore, and then possibly native VLANs that will be used for the trunk ports. So no more than 5 VLANs on an access layer switch. The default VLANs, you have VLAN 1 and 1001 through 1005, and I already mentioned the defaults, VLAN 1. All right, so design philosophies, spanning tree bad, routing good. If you have a really complex spanning tree environment, it's going to take a week to figure out where the route is, what paths are forwarding, what's blocking. Keep it simple. Right? Simpler you make spanning tree, the better. There should only be, in my designs, 3 devices, and hey, no loops. I can create a really good network with 0 loops and still have all the redundancy in the world. I could literally show you a method that you could build a network and shut off spanning tree almost safely. It's safe until somebody plugs that one box into the wrong port, and then you have a big spanning tree loop. So I don't suggest turning it off, but all right. Always plan with security in mind. I don't need to tell you that. All right, so here's a good design. And I also put a link up there for Cisco's best practices on design. I don't have enough time to talk about all the good design philosophies, but this is what it's going to look like, and Cisco calls this their switch block. Now I could have a switch block designed for users, a switch block designed specifically for my servers, another switch block that runs specifically through my core. The design is simple from the standpoint of we have these 2 boxes on top, which have the router modules built in, a multi-layer switch, and we have just simple layer 2 switches below, which handle user access. The access layer switches kept very simple. 2 user VLANs. The reason why you use 2 user VLANs is we're going to load balance the distribution layer switches instead of loading all the traffic onto one. Now, that's as far as I can get into with that. But often when I go and look at networks and figure out what's going on and why the network's been hacked into and why it's insecure, I end up seeing this. This is the MOS design network, right? Or the mold design. We started with this box, and then somebody needed connectivity over here, so we just ran a cable over there, right? And then somebody else needed a connectivity like 20 feet away, and so we just put another switch in there, and now we needed some redundancy, so we just connected a bunch of cables here, and okay, where's the route? What ports are forwarding? Which ones are blocking? And this is the simple version of the rat's nest. So a good method to figure out whether you have a good design or a bad design is the dartboard test. Print up a Visio document of your network and throw a dart at it. Thunk. Okay, that device, just pretend that device goes down. Is your whole network down because that one device went down? If it's down, you got a bad design. All right. All right, so back to VLANs here. I kind of talked about it a little bit. VLAN 1 is dead VLAN. Don't use it. Clear it off all your trunks. Kill it. Here's why. Every single port on every Cisco switch is defaulted for VLAN 1. Even if I get rid of it, I don't clear it off completely, it doesn't stop somebody from walking in with widget switch 2000, walking into my network, sitting down at some empty, unoccupied desk, plugging into the network, and they're on VLAN 1. VLAN 1 is the default for all the management protocols. So there's CDP that you left running because you had to use Cisco Works 2000. Oops. So kill it where you can. You can't remove it from the switches, but you can stop trunking it. Don't send it everywhere. Don't send any traffic into it. Change all the switches so it doesn't use the management VLAN for VLAN 1. There's still some problems with it. Sometimes routers still send CDP message over VLAN 1, certain revs, so you're going to figure that one out, okay? Be careful with it. There's a way, a good way to compromise a network is right through VLAN 1. You have the other VLANs, 1001 through 1005, the dead technology VLANs, things like token ring and FIDI. That's what those are there for. If you don't have any token ring ports on your routers, I wouldn't even worry about them. Who's going to compromise a network if you don't have the access to get into those ports? And you can't use those VLANs for Ethernet anyway. So clear all the trunks of VLANs that are listed here. You have to have at least Cat iOS 5.4 or later to clear VLAN 1 off, so upgrade your switches if that's the case. Setting up a management VLAN. Like I said, defaults to 1. You want to change this on all your boxes, so now you're going to be carrying information like your routing protocol information over the management VLAN. You're going to carry CDP if you're running it, VTP, VLAN trunking protocol, if you are brave enough to run that, multi-layer switch protocol, and any other type of protocol that's needed between Cisco boxes that may show up here in the future that you don't want or need or have any reason to send to your users. Because if you're sending it to users, they can maliciously use it against you. A lot of these attacks that FX and other people that you read on the internet kind of rely on seeing this information, on seeing the routing protocol, seeing the RIP updates, IGRP updates, etc. If the users don't see it, it's real hard to run a lot of those exploits. The only problem with this, and the one thing I didn't put in here, is HSRP. Because you have to run HSRP on the user VLAN. It's the only way it can run. You're going to run an instance of HSRP on every single one of the user VLANs for router redundancy. So we'll get to that one separately. All right, so to illustrate the point here, management VLAN, every switch in this switch block belongs to the management VLAN. This link up on top, the only thing running across that link in a good design would be the management VLAN. The effect of that is you create a layer 3 link between those upper boxes. So should you lose one of these side links here, the router will end up routing across the management VLAN to get the user traffic that way. Okay? Otherwise, the user traffic should never be on the management VLAN. Or an even better method is to not only truck the management VLAN across that network, but a separate VLAN in the event of emergency, okay, that you would use instead of the management VLAN. Okay, so the management VLAN would get trunked with all of the user traffic as well. All right, other issues. Spanning tree issues, VLAN trunking protocol, which it's another one of those administrative denial of service attacks. You do it to yourself, okay? Dynamic trunking protocol, to trunk or not to trunk? All right, spanning tree. Been around since the dawn of Ethernet. It's a complex protocol that just keeps growing on us. We just keep adding more and more features to it, and it won't go away. Cisco's added more features into spanning tree that's even believable. The exploits against this, documented by FX and various other people. What happens if I'm sitting on a box and I start sending out bridge protocol data unit traffic? I could deny service to the network, or I could take over and act as the root bridge. So I need ways to prevent this. And every single VLAN on a Cisco network should be running an instance of spanning tree. Okay. Now that goes against the rules with .1q, which is the idea of a common spanning tree, and Cisco disagrees, and I agree with Cisco that you should be running per VLAN spanning tree. Problem is it opens you up to attack. How do you mitigate these problems? You want to force the users to not send or force the user ports to not send or receive any BPDU traffic. There's another big advantage to this a lot of people miss, other than just the simple security side. The commands to do this: port fast and BPDU guard. Now, port fast and BPDU guard, great tools. There's this little problem that I always used to run into on switch networks. You'd get, the user calling up saying, every time I turn my PC on, I can't get on the network. But if I do a release renew, I come right up. The reason is spanning tree takes about 60 seconds to converge. If you have a fast enough PC, turn the machine on, 40 seconds goes by, and the first thing it sends out is a DHCP request. But the port on the switch is still spanning tree blocked and not sending any traffic. Oops. What happened to your DHCP request? Went down. So Cisco's solution was port fast. Now port fast does another really cool feature. It stops sending BPDUs down to the user. The other thing it does, and this is an unintentional side effect of switch networks that a lot of people don't know, is that when you turn on a PC without this port fast feature, the link light on the switch goes up, which says, uh-oh, there's a spanning tree topology change. And it sends this topology change flag and floods it through your whole network. Sends it all the way up to the root switch, or root bridge. And the effect of that topology change flag is every single switch fast ages their entire CAM table. So instead of the normal 3-minute aging time, now it's down to 15 seconds for all the CAM entries, which could end up with one PC turning on for a few seconds, flooding a lot more extra traffic across your network than necessary. This is a command, again, regardless of security issues, you should have on for all user ports. Port fast. BPDU guard goes one step farther. If a port fast port sends a bridge PDU, error disable that port. Shut it off. Because it's obviously not a user. There's a switch attached there, and if there's a switch or some application that's sending bridge PDU traffic, like these attacks, if it sends a bridge PDU, shut it off. Then you have all the options of what you want to do with it. You can bring it back up in 6 minutes. You can force an administrator to go out there and figure out what's going on. You have all those options available to you. All right, VTP. Cisco's idea of maintaining a consistent VLAN database. Really cool if you got lots of VLANs. In a good switch block design, you're going to keep it pretty simple at max 5 VLANs per access layer switch. So it kind of takes away the purpose of this protocol. There's also a big problem with this protocol that's been documented over and over and over. The problem is that all Cisco switches are considered VTP servers, meaning they're serving up the VLAN database. Now, what's happened in several networks I've dealt with is they've got an up and running network with 15, 20, 30, 100 VLANs. Scary networks. And somebody comes in and plugs in a brand new switch that they've been playing with in a test lab for days. And it comes up and says, oh, I'm the VTP server. My revision number is way higher than everybody else's, but I don't have any VLANs. Because I have the highest revision number, my database is the most correct. So everybody just delete your VLANs. And it's happened many times. Cisco says they fixed it. I haven't tested it. I'm too scared of it. Sorry. Set all your switches to VTP transmit mode, create the VLANs individually on each switch. You'll be happy. You're never going to have any problems. If you want to play with it and be brave, be my guest. I haven't heard of any specific attacks against VTP, but they're certainly out there. Well, they're certainly possible of creating them. I mean, look what you have here. You have a protocol that's going to change and configure VLANs. What could I use that for? Send a false request. Hey, I've got this new VLAN. I'm a server. Add VLANs to the VLAN database. Now you can trunk that VLAN. Now I can carry VLAN traffic over something that didn't exist before. Or delete VLANs that, going to the servers. Another thing that's turned on for all your 100 meg ports is dynamic trunking protocol. Now DTP on all the Cisco switches is defaulted to auto. You connect two switches together, it's auto, auto on both sides. Is it a trunk? No. Kind of funny math here. Auto, auto, not a trunk. If one side's on, the other side's auto, it becomes a trunk. And then they've got all these goofy other options like desirable and non-negotiate. And you know what? If I'm creating a trunk, I want to set both sides to on and hey, it's a trunk. Great. Here's the attack problem against this though. What if it's a user port? And that user is running an 802.1q aware trunking capable network interface card. That means I could trunk down to my workstation. I could start seeing all the VLANs and putting traffic into whichever VLAN I darn well desired. Oops. So, if it's a user port, turn DTP off. Another method here, which is to force users down to 10 meg. 10 meg ports on Cisco switches don't trunk. Okay? And I have this little lead balloon thing here. Yeah, you tell all your users they're going to run 10 meg, it'd probably go over like a lead balloon. In a large network, you can save a lot of money by going 10 meg because your uplink ports up to your other switches are going to be a lot smaller. You're going to need gigabit links or gigabit ether channel going up to and around your whole network by pushing 10 meg, and most users aren't even coming close to pushing a 10 meg full duplex pipe, let alone a 100 meg duplex pipe. So that's my solution for today, but 6 months from now I'm going to change my mind as things start getting faster. All right, so these CatOS commands to do this. Great command. This is going to help you a lot. Set port host. Set port host and put the module and port number does two things. It sends the dynamic trunking protocol to off and it turns port fast on. One command. Another thing you may want to consider is if it's not a used port, shut it off. Set the port to disable. Okay. Somebody plugs in, then turn it on. Set span tree port fast BPDU guard enable. You don't have to assign a port to it. If you have any port fast port, BPDU guard gets turned on. Okay. Set spanning tree guard root. Here's another issue I didn't really cover in detail. I kind of touched on it, but if I had the ability to start sending BPDUs and saying, hey, I want to be the root of the network, this command will guard the root and make sure this box is set appropriately so he's always going to appear as the root of the network. So it will ensure that this device maintains the root for spanning tree. The more I talk, the more I want it. This cold starts getting worse. All right, so some of these techniques here. VLAN hopping. VLAN hopping works by injecting modified 802.1q tags. Now that can be done without a trunk via a 10 meg port. Right. As long as I have a network interface card that'll do this, I can modify the TCI TPI header inside the Ethernet frame to basically say that I'm on a different VLAN than what I really am on. And as it arrives at the switch won't change it. So this allows me to illegally, without traversing a router, walk onto another VLAN, and it will actually send traffic back if I don't use this technique. The technique to solve it is to change the native VLANs on the trunk ports. The reason why is that when you do VLAN hopping, it's depending on one of the properties of untagged frames for .1q. If an untagged frame arrives on a trunk port, it automatically tags it with the native VLAN. If that native VLAN so happens to match what we were coming from in the first place, we're going to be able to hop VLANs. So the desired method here to fix this is set the native VLANs on all your trunk ports to a VLAN that is not being used by either management or users, or being used elsewhere in your network. It does have to match both sides of the trunk. So you're just simply going to create a VLAN to trunk between two boxes. It still trunks. The idea is if that trunk ever went away or it needed to tag something, it would use the native VLAN for the tag. So Oh, my little mistake here on the switch. All right, this has to deal with network switching on network sniffing on switch ports. If I'm sitting here with an attack box here, running my hack utility, and I start running unsolicited ARP requests, start modifying ARP tables on the PC so I can do this man-in-the-middle attack between PC and server. This is a really hard attack to defeat. I'm going to be honest with you. Cisco's solution, I hate it. Read Cisco's website and they say, oh, set up private VLANs. And you got to have a 6500 switch to run private VLANs. So everybody's just going to run out and go buy 6500s for every part of their network so they can, solve this problem. I don't think so. I put host IDS on here. That was incorrect. It was network IDS. Right? If you have a network IDS on the network and it starts seeing these these unsolicited ARPs, that should start triggering things. Now, you might end up with some false positives on this, but if you start seeing a lot of it, then that's something you should shut down. I think that might be, for now, the best bet on solving this attack. That's my opinion. Anybody else got any ideas on that?
Network IDS with one machine looking for segment or ARP watch.
ARP watch, okay.
You can also, if the machine switch has less than data, you can extract some of that via, again, ARP watch.
Yeah. Okay, so. All right, another well-documented attack is to flood a switch with tons and tons and tons of MAC addresses, filling up its content addressable memory, its CAM table. Once that memory table is filled up, most switches will operate like a dumb hub at that point. Will forward all traffic as it's an unknown unicast, just like the first time a packet shows up on a switch and it doesn't know what to do with it, giving you ability to sniff the network on any port of the switch. So the solution for this, and this actually solves, I think it may solve the problem that we see next. I'm going to test that and find out what's happening. So I want to figure that out. But turning port security on. Port security will allow you to learn or statically set a single or multiple MAC addresses to a single port on a Cisco switch. It will therefore not learn any more addresses or utilize any more addresses on that port. Port security is a great solution if you have a static environment. If you have people moving around all the time, it's a pain. You have people coming in with laptops every single day and moving things around. It's almost more hassle than it's worth. But it will solve this particular problem and a few other ones. All right, I'm getting the 5-minute signal here, so I'm going to have to run a little quicker here. All right, access control lists, standard, extended, named. We have context-based access control. Standard and extended IP access list. Here's the ranges for it. IP standard only uses source address. Extended looks at source destination, both for IP and for ports. Also looks at protocol, looks at establish either a SYN or a reset bit, and both of these can be logged. Here's the numbers for it, et cetera. You can also use named access lists. CBAC, context-based access control, is what was formerly known as the firewall, well, actually currently known as the firewall feature set. It's the equivalent of a semi-stateful inspection firewall function at a router. The idea is you create a rule set on the ingress of the router that says the equivalent of deny any. As a packet exits the router, CBAC will inspect the packet and create an inbound dynamic access list entry to sit on top of your deny any. So as the traffic returns, it allows the traffic. It sits there for a short amount of time and removes the dynamic entry. So, cool feature. It's not a firewall, not a full-blown stateful inspection, but it's a great tool to use like as a screening router, like in front of your real firewall. The reason why it's got its issues is that it is still suspect to problems with IP fragmentation and so on. So, all right, other types of access lists. You have reflexive and dynamic. You can do time-based access lists on Cisco routers now. All other kinds of access lists for other layer 3 and layer 2 protocols for MAC addresses and NetBIOS. There's even VLAN access control lists now. All right, our routing protocols. RIP, IGRP, EIGRP, and OSPF. I didn't put BGP in because I'm running out of time, so it's a good thing I did put it in here. RIP issues. You have version 1 and version 2. Now, all of the issues with RIP, version 1 basically sucks, okay? And it's still out there, and every single vendor who's ever made a router that's been called a router runs version 1 of RIP. But please stop using it. Version 2 does support MD5 passwords, but it still has, 30-second broadcasts. It's still vulnerable to plenty of attacks. You shouldn't use it. But if you're going to use it, here's the commands to set up a keychain and use the MD5 keychain for version 2 of RIP. Fair enough. IGRP, and my previous slide up there, I said I'd rather run RIP before I ran IGRP. IGRP is about the most insecure routing protocol. It's slower to converge than RIP. Yeah, it figures out the metrics based on bandwidth and delay of the network, so it's not hop count, so it might choose a better path. But other than that slightly little better feature, it's not worth the time. It's still out there because of the CCNA program, because during the CCNA, if somebody goes out and goes and get their CCNA, the two routing protocols they learn, RIP and IGRP. The two routing protocols that probably shouldn't be running on your network. My solution, great solution for IGRP. If you're running IGRP, just go out to all your configs and put an E in front of IGRP. It'll solve all your problems. Enhanced IGRP, much better routing protocol. It acts like a link state routing protocol like OSPF. It goes out and discovers neighbors. It creates a topology table. It looks at the exchange routes. It's the fastest converging routing protocol, better than OSPF. It also acts like a distance vector routing protocol for calculation of metrics. It does support MD5 passwords for creating neighbors. Where'd my router go? That's weird. So there's supposed to be a router here. Router EIGRP. Another thing you're going to want to do here on EIGRP is set passive interface. Now, I like using the passive interface default command. The most common misunderstood thing with routing protocols is that network statement. The network statement does not advertise a network with your IGPs. Now, that's not true with BGP, but for OSPF, RIP, IGRP, ISIS, the network statement turns up an interface for the routing protocol. It's going to go out and start sending whatever kind of messages the routing protocol is going to send out those interfaces. And it's based on class for everything else but OSPF. So if I have multiple interfaces on the 192.168.1 Class C network, EIGRP goes out all those interfaces, even if there's no devices out there, even if there's users out there, which we don't want to be sending this information. So I use the passive interface default, and then I do no passive interface to turn those interfaces back on to run EIGRP. The commands for setting the authentication mode are all there as well. All right, OSPF. Actually, let's see. How much more time do I got? 1 minute. Okay, I'm skipping OSPF. Same information. I went into HSRP because of our problem here. HSRP is not hot swappable routing protocol. It's hot swappable router protocol. It doesn't carry routes. It's for high availability of your routers. The idea is that from a Windows PC, from most host machines, you only get one gateway address. Should that gateway go down, there's all these other tools, IDRP and so on, that really, even without the other attacks that we can run against it, they're slow as dirt. It may take as long as 30 minutes to figure out that the gateway's down. By that time, I can reboot the PC and put a new gateway address, and what's the use of running the protocol in the first place? HSRP talks between two routers to create the illusion that the gateway belongs to a virtual address. And should one router go down, the active router go down, the standby router will take over and start forwarding traffic for that virtual address. But it is vulnerable to attack because when Cisco created it, they didn't put any strong password protection on it. It does have a clear text password, which you could easily snoop and grab. And because you have to run HSRP on every single VLAN, including your user VLANs, it's pretty accessible and everybody just pretty much grab it. Here's an illustration of the attack. Normal packet flow would go out the active router. In this case, we have the altered packet flow because this guy used a denial of service attack that said, send an HSRP message to the group address that says, hey, I'm the active router. So now the PC's sending the information over to the attacking device, who then forwards it out as if it was normal traffic while he's looking at it and modifying it or doing whatever you want to do. All right, so here's solutions, my last slide, I think. Yes, other than the links. Set the HSRP priority to 255 on both routers. That's the highest priority you can set it to. Now what's going to happen is the two routers are going to start fighting. So who wins? The one with the highest IP address. So the next solution is, for the active router, the device you want to be active, give them the highest address in the subnet. For the standby router, give them the second highest IP address in the subnet, and for the virtual address, give it a third address. Or actually, the virtual address can be anyone. But the idea here is it's going to defeat some of these tools that just try and brute force and take over. You're not going to be able to take over if you can't take the two highest addresses in the subnet. Well, maybe. Just going to make it more difficult. Modify the default MAC address for HSRP. The HSRP MAC address it uses has the group number in there. So if you have the MAC address, you know the group number. If you know the group number, it's easier to make the attack. Change that. Another thing you can do is you can apply access list only permit HSRP traffic. It's UDP 1975. I don't know. Look it up. You can create an access list to make sure the UDP traffic from that port is only coming from the other HSRP router. I don't like that solution if you're running multi-layer switching. Multi-layer switching and access lists across user VLANs turns your switch into a router because it creates this huge CAM-tail forwarding information database, and it's messy. So I don't like it. But if you're not running MLS, hey, great solution. You can also hard code the 224002 address on your switches to make sure they're only forwarding up to routers. Now that may have some implications with multicast routing, CGMP and IGMP snooping. So if you're not doing multicast routing, that solution's okay. If you are, well, then okay, that's it. Here's a copy of the links, some of the things I pulled from for my presentation. I'd like to thank everybody for coming. Sorry I had to speed through the last couple slides. Special thanks to Jeff and Black Hat and everybody else, and it's a lot of fun. Thanks, guys.